Okay, so here goes our sixth module. It is based on mass transfer. As we know, the subject is related with the heat and mass transfer. So for the first five modules, we have studied about heat transfer, several types of heat transfer. Like last session, we have studied about radiation heat transfer also. So first five modules are related with the heat transfer, different types of heat transfer, conduction, convection, radiation. And therefore, our sixth module is based on mass transfer. Okay, mass transfer is something related to something liquid, volume, pressure, temperature, etc. Number of moles, molar concentrations, something terms related to the particular chemistry. You have studied about the particular mole fraction, mass fraction in our late plus two related or associated subject like chemistry. So that is a primary principle of this module, that is mass transfer. So what is a mass transfer usually referred to? So we know that for every liquid or every system there is occur a concentration. Concentration means ശ്രദ്ധയല്ല. Concentration ലായനി ഒരു ലിക്വിഡിന്റെ കോൺസെൻട്രേഷനെ കുറിച്ച് പറയാറ്. So you know that there is a typical any liquid or any gas or any solid or any substance occur a particular level of concentration. So some particular substance have lower concentration, some particular have higher concentration. In a particular system also there occur a higher concentration region and lower concentration region. Okay. Therefore, in any system consider one or more components. Particular system contains one or more components whose concentration vary from one point to other point. When concentration vary from one point to other point, the concentration gradient occur. That is like temperature gradient itself. Any concentration level of higher or lower level occurs, which means that a concentration gradient occurs. There is a natural tendency of the transport of different species from region to higher to those of lower concentration. Some particular mass or some particular substance or different species have a tendency of a natural tendency to move from a higher concentration to lower concentration. Temperature higher level like a particular level of if there is a particular level of higher concentration and a lower concentration, there is a natural tendency of moving a particular mass or a particular substance from a higher to lower. And that type of transfer from a higher concentration region to lower concentration region, a particular substance movement of particular substance from a region of higher concentration to lower concentration is termed as mass transfer. Is the movement of mass transfer is the movement of, or it's a transport of transfer of substance or species from a region of higher concentration level to a lower concentration region is termed as mass transfer. Higher concentration region to a lower concentration region. Okay. So that is important for a concentration itself. Concentration ആണ് ഏറ്റവും വലിയ ഇമ്പോർട്ടൻസിൽ വരുന്നത്. Okay. There is a transfer of higher level of higher concentration region to lower concentration region. This is known as mass transfer. So a particular simple day-to-day example for a mass transfer is dissolution. Dissolution means ഉപ്പ് വെള്ളത്തിൽ അറിയുന്നില്ല. Sugar dissolves in water, salt dissolves in water. It's a particular day-to-day examples of particular mass transfer. When we pour a particular salt or particular sugar into particular water, after some time it melts. It melt or it the particular mass. There is a change of phase occurs, and there is a particular type of mass transfer from a system of solid to particular liquid surface. That is a typical example for a mass transfer. So, what are the different modes of mass transfer? There are mainly three modes of mass transfer. As we studied that there are three types of modes for a heat transfer, that is conduction, convection, radiation. Three modes of heat transfer, that is conduction, convection, radiation. So as like that we have three modes of mass transfer also. Modes of mass transfer can be divided into first one Mass transfer by diffusion. Mass transfer by diffusion. Okay, diffusion. And second one is mass transfer by convection. Mass transfer by convection. And third one is, and last one is mass transfer by change of phase. Mass transfer by change of phase. Change of phase means there are three types of phase we study, that is liquid, solid, and gas. From a particular, when the particular solid changes to a particular liquid by heating, you can term it as a phase difference. So phase transformation from a solid to liquid. So mass transfer by change of phase. Change of phase. These are the three typical examples for a, or typical modes for a mass transfer. First one is mass transfer by diffusion. So what is diffusion usually termed to? Diffusion. Diffusion. Diffusion is aligned. So that is a transfer of particular, or it occurs when a substance diffuses through a layer of stagnant fluid. It may be used to particular concentration gradient. It is occurred due to concentration gradient. Particular substance is dissolved into a particular liquid region. That is simply called as mass transfer diffusion. As I said, there is a typical example of particular sugar dissolves in water, or sugar dissolves in tea, or salt dissolves in water, etc. When it occurs due to the particular substance when dissolved or diffused through a layer of stagnant fluid. Through diffusion. Diffuse, when a substance diffused through a liquid region. Due to a special concentration gradient itself. It occurred due to concentration gradient. The all three transfer occurred due to concentration gradient itself, from a region of higher concentration to lower concentration. So first one is mass transfer diffusion. It is simply termed as the dissolution or dissolving or diffusion of particular substance to a liquid region due to some concentration gradient. It is known as mass transfer by diffusion. On the term diffusion. So second one is mass transfer by convection. Mass transfer by convection. As you know, the basic examples for a convection is a evaporation itself from a region of solid to particular atmosphere. It is the transfer of particular heat. Heat transfer by convection is the particular example. We can define that there is a heat transfer due to some heat exchange from a solid surface to particular atmosphere. ഒരു വാക്വവും ഒരു സോളിഡ് സബ്സ്റ്റൻസും തമ്മിലുള്ള ഡിഫറൻസ് ആണ് കൺവെക്ഷൻ നടക്കുന്നത്, അല്ലേ? നമുക്കറിയാം particular component is the surface is there, and particular atmospheric air is there. Heat is transferred from a region of surface to surrounding system. Heat transfer by convection. There also mass transfer by convection is the same definition as like that conduction, heat transfer. That is, mass is transferring from a region of a surface of a solid substance to atmosphere. Okay. Take an example of evaporation. There is a particular water droplet. There is a particular mass of water droplet on the surface of particular solid surface. And by heating or by particular by convection process, that is evaporating into atmosphere. Evaporating to atmosphere. So our mass transfer നടന്നു. Liquid അവിടെ ഇല്ല, പിന്നെ അവിടെ ഇല്ല. Droplet is escaping to atmosphere. Okay, there is a transfer of mass due to convection. So that is a particular example for a convection process, evaporation. Okay. So first one is mass transfer by diffusion. Second one is mass transfer by convection. And last one is mass transfer by change of phase. Mass transfer by change of phase. When a particular substance is changing its phase from a solid to liquid, there are three types of phase change. That is solid, liquid. That is fusion. Fusion, right? Liquid, gas. That is evaporation, right? Fusion, evaporation, and last one is solid to directly to gas. Not gas, it is vapor, right? Vapor ആണ് കേട്ടോ. Vapor എപ്പോഴാണ് ഗ്യാസ് ആവുന്നത്? What is the difference between vapor and gas? Vapor is a symbol particular related to hydrogen and oxygen itself. It is a particular region of ഒക്കെ എപ്പോഴാണ് വേപ്പർ ഉണ്ടാവുന്നത്? ആഫ്റ്റർ ഹീറ്റിംഗ് ഓർ വേപ്പറൈസേഷൻ നടക്കുമ്പോഴാണ് വേപ്പർ ഉണ്ടായത്. ഇറ്റ് ഇസ് സാച്ചുറേഷൻ സ്റ്റേറ്റ്, അല്ലേ? When a temperature reaches above its boiling point, that is saturated state, above 100 degrees Celsius, vaporization takes place and vapors are formed. Okay, and again we are applying heat, and there is a particular saturation temperature. ഒരു full liquid vapor temperature, maximum saturation temperature is there. And when we apply heat more than that particular saturation temperature, okay, when we apply heat more than its saturation temperature to vapor and heat so liquid, whole liquid changes to vapor. So then we are heating, that particular temperature of vapor increases above the saturation temperature, and that particular temperature above saturation temperature is known as superheat temperature. That is known as gas. Superheated vapor, that is known as gas. That is the difference between gas and vapor. Above saturation temperature, that is gas, and below saturation temperature or in saturation state, it is vapor. So liquid vapor region, that is evaporation, and solid to gas directly known as sublimation. ഇതൊക്കെ പഠിക്കേണ്ട ആവശ്യമില്ല, ഇതൊക്കെ അറിയുന്ന കാര്യങ്ങളായിരിക്കുമല്ലോ. Solid to liquid, that is the three types of phase transformation is the liquid, solid to liquid, either liquid to solid also, freezing, liquid to solid also, ice cut. So there are different types of phase transfer. So mass transfer by change of phase is known as the third mode of mass transfer. For example, when we are heating a particular liquid, the particular liquid changes to vapor above the 100 degrees Celsius. The water boils and it changes to vapor. There is a transfer of mass from a liquid to gas. A change of is നടക്കുമ്പോൾ the amount of that particular liquid reduces. The amount of liquid reduces and it changes to vapor. And the particular mass is transferred into atmosphere. Right? Mass is transferred into atmosphere, and that particular vapor releases to atmosphere, dissolved in atmosphere. Atmosphere area. Right? So there is a mass transfer due to change of phase from a liquid to vapor state. There is a change of phase. Okay. So there are three modes of mass transfer. First one is mass transfer by diffusion. Second one is mass transfer by convection, and third one is mass transfer by change of phase. It's a very important points. Okay, clear line.
Yes, sir.
Okay, done. So thereafter, we want to know about what is concentration, what is molar concentration, what is mass concentration, and what is mass fraction, and what is mole fraction. Mass fraction, mole fraction, mass concentration, molecular concentration, or molar concentration. So we can move to is concentration. Concentration, we have said that concentration is particular liquid in the garden. So there are two types of concentration. First one is mass concentration and molar concentration. Mass concentration simply known as mass density itself. Mass concentration or mass density. Mass concentration or mass density. Take any particular mixture of gases. It's a particular system. It occur one or more component. One or more component. Okay. Take one component as A, one component as B. Okay. As a C is there, D is there. If the number of substances is 5, we have A, B, C, D, E. Anything you can take. So I'm taking here. There are two types of substance in a particular system. A two type of system together constitute a particular two type of substance together constitute a system. Okay, mass concentration or mass density. Mass concentration or mass density. First one, it is can be defined as the mass of a. We can say, take an example. If rho A for a substance A, mass concentration rho A for a substance A. If we are taking B, there is rho B. Okay, therefore mass concentration or mass density rho A is defined as the mass of A per unit volume of the whole mixture. Mass of A, rho A, mass concentration. You can say mass density or mass concentration rho A of species A can be defined as mass of A per unit volume of mixture. എന്ന് വെച്ചാൽ when we are taking a particular one per unit volume അല്ലേ, when taking one volume, ഒരു particular 1 unit volume എടുത്താൽ particular there are any and we are taking any region here, there is a mixture of A and B, right? There is a mixture of A and B. Any region, any point we are taking, any volume we are taking, there is a mixture of A and B. The total A and B constitute the whole system. So rho A, mass concentration of rho A, that is rho A, is defined as the mass of A for the mixture. That is, we are taking a particular volume here, taking a volume here, and there are A and B. If A is of 3 kilogram and B is of 2 kilogram, for example, you're taking, so total it is 5 kilogram. Taking a particular system 5 kilogram ആണെങ്കിൽ mass density of A is termed as 3 kilogram from the whole mixture. Mass density of A is 3 kilogram for the whole mixture, and mass density B, rho B, is 2 kilogram for whole mixture. So it is not 2 and 3 villa, and we are taking as unit volume, right? Unit volume is taking. So here 1 kilogram volume, when we are taking 1 kilogram volume, the percentage of A in that particular mixture is known as mass density of A, and the percentage or kilogram or mass of the particular B in that particular compound is mass concentration of B. That is simply example of particular definition of mass concentration or mass density. It is the mass of A. If we are taking rho A, it is a mass of A in the particular mixture, unit volume of mixture. Okay, rho A or rho B. And second is molar concentration, that is mole concentration. The same definition here. The same definition here we are taking. Here rho A, give the C. C is the term. Here rho mass concentration denoted term rho. Molar concentration C. The molar concentration Ca is defined as the number of moles of species A in that particular unit volume of mixture. Okay, Ca is defined as number of moles of species A, number of moles in per unit volume of mixture. Unit volume of mixture. First one is mass, second one is number of moles. That is simply example definition of mass concentration and molar concentration, number of moles and mass. Okay, then what is mass fraction and molar fraction? Mass fraction and molar fraction or mole fraction. Mass fraction MA star of particular M star. If this is a particular species M, A angle, we can call it as MA star. MA star is defined as the ratio of mass concentration of species A to total mass density. Okay, MA star of species A, MA star, mass fraction of particular compound A, is defined as ratio of mass concentration of A to whole total mass concentration. Mass concentration of A divided by whole concentration. It is mass concentration of simple whole system is defined as rho. Like total system is, for a total system it is defined as rho, mass density rho and molar density C. If we are taking for a species A, we are taking rho A. For B, we are taking rho B. If C is the, we are taking rho C. If Ca is the total number of moles, we are taking Ca as the number of moles for species A, Cb as for number of species B. Okay, so we can define as mole fraction, or sorry, mass fraction defined as the number of the mass of species A, mass concentration of species A divided by total mass concentration, rho A by MA star is defined as rho A by rho. MV star is defined as rho B by rho. That is number of or total mass concentration of species A divided by total mass concentration is named as mass fraction. Mass fraction. Okay. ലോജിക്ക് വെച്ച് മനസ്സിലാക്കിയാൽ മതി. Then next one is mole fraction. Mole fraction. Mole fraction is defined as number of moles of species A divided by total number of moles. Right? XA. It is defined by X or XA of this mole fraction. XA is defined as ratio of molar concentration of A to total concentration of mixture. Total molar concentration of mixture or whole molar concentration of mixture. That is, XA is known as CA by C and XB is known as CB by C. Okay, this is the simple explanation of mass fraction and mole fraction. Okay, mass fraction and mole fraction. So we can relate or we can write some relations related to some relations respect to binary mixture. These two unknown binary mixtures A and B. Binary mixtures and A and B would mixture respect to binary mixture A and B. Relations respect to binary mixture A and B we can write for a system that is occurring for total A and B system. Binary mixture of A and B, we can write that rho A plus rho B equal to rho. Simple. Total mass concentration is the simple mass concentration of its constituents A and B, and CA plus CB equal to C. CA plus CB equal to total molar concentration is the individual molar concentration, summation of individual molar concentration. The summation rule. And next one is MA star plus MB star equal to 1. It is not total MA, it is 1. Total mass fractions of first one and second one is called 1. And one of that is if we are taking rho A by rho plus rho B by rho, that is rho in denominator size the whole rho A plus rho B by rho, that is rho A plus rho B equal to rho, right? Rho A plus rho B equal to rho, so we can write rho by rho equal to 1, and then M star plus MB star equal to 1, and also we can write XA plus XB is also equal to 1. XA plus XB equal to 1. Okay. Done. So according to this particular definitions and relations, we can write a simple problem to understand the application of particular relations, to understand the particular examples of relations and particular equations of mole fraction, mass fraction, etc. So please write down a simple problem to understand the ideas of mole fraction, mass fraction, etc. Please take a notebook and write down the molecular weight of two components. The molecular weight of two components A and B of a gas mixture are 24 and 28 respectively. 24 and 28 respectively. The molecular weight of gas mixture is found to be molecular weight of A and B is given as 24 and 28, and total molecular weight of mixture is given by 30. Okay, 30. If mass concentration of mixture is 1.2 kilogram meter cube, 1.2 kilogram per meter cube, determine the following. First one, molar fractions of A and B ആണ്. Molar fractions. A and B എന്ന് പറയുന്നില്ല, പക്ഷെ fractions എന്ന് വെച്ച് കഴിഞ്ഞാൽ you can find the both molar fractions. Second one, mass fractions. Third one, last question is total pressure if temperature of mixture is 290 Kelvin, 290 Kelvin. So pressure and temperature are also there. So if pressure and temperature occurs, we nothing want to do. We only want to take the relation PV equal to RT, our normal thermodynamic relation, that is for a gas law. It is a particular examples for a gas, and all the equations were related to pressure. And so we are taking the equation PV equal to nRT, or PV equal to mRT, or PV equal to nmRT. M into R is known as M into R. R is characteristic gas constant, and M into R means universal gas constant, 8.314. PV equal to RT means that particular R is known as characteristic gas constant, that is I think it's 0.287 kilojoule per kilogram Kelvin, right? 0.287. And if M also multiplied by M into R is known as universal gas constant for gas law, it is taken as 8.314, right? 8.314 kilojoule per kilogram mole Kelvin. 8.314. M into R, MR, total G in order. Therefore, the given data are molecular weight of two components A and B is given. Sorry, MA and MB is given. MA and MB is given. Capital MA. MA is given. MA is given as molecular weight of A is given as 24. MB is given as 48. 24. 28 ആണല്ലേ. Sorry, this 48 ആണ് question. Sorry, please change it. 48. Sorry, 48. Total M is given as, it is not MA plus MB. MA plus MB is not M. Molecular weight on top. M is given as 30. And mass concentration rho. Rho is given as 1.2 kilogram per meter cube. Temperature is 290 Kelvin. So you must find out first the molar fractions, mass fractions, and total pressure. And before we finding the particular 1, 2, and 3, we want to find particular relations. Rho A, rho B, M A, X A, X B, something. Okay, particular values of individual values of rho A, rho B, we want to find out by our relations, the particular relations. Relation വെച്ചിട്ട് നമുക്ക് ആദ്യം അതിന്റെ വാല്യൂസ് കണ്ടുപിടിക്കണം, എന്നിട്ടാണ് നമ്മൾ സബ്സ്റ്റിറ്റ്യൂട്ട് ചെയ്യുന്നത്. സോ ഇനീഷ്യലി വി നോ ദാറ്റ് ദർ ഈസ് എ പെർട്ടിക്കുലർ, ഞാൻ പറയാൻ വിട്ടുപോയ ഒരു കാര്യം ഇതിന്റെ കൂടെ, ദർ ഈസ് എ പെർട്ടിക്കുലർ റിലേഷൻ ബിറ്റ്വീൻ മാസ് കോൺസെൻട്രേഷൻ ആൻഡ് മോളാർ കോൺസെൻട്രേഷൻ. അത് വിട്ടുപോയി, അത് ഇവിടെ എഴുതി വെച്ചോ, ബോക്സ് ആക്കി വെച്ചോ. റിലേഷൻസ് ബിറ്റ്വീൻ മോളാർ കോൺസെൻട്രേഷൻ, അത് എവിടെയാന്ന് വെച്ചാൽ എഴുതി വെച്ചോളൂ. മോളാർ കോൺസെൻട്രേഷൻ ആൻഡ് മാസ് കോൺസെൻട്രേഷൻ. Molar concentration and mass concentration. Relation between molar concentration and mass concentration is Ca equal to, for a particular species A, for a particular species A, we can write Ca equal to rho A by Ma. Ca equal to rho A by Ma, or Cb equal to rho B by Mb. Here Ma equal to molecular weight of A. So rho A is mass concentration of A, Ca is molar concentration of A. So we can write C equal to rho by M. That is C equal to total molar concentration, rho equal to total mass concentration, M equal to total molecular weight of particular mixture. This is a particular case of mixture. Is a case of A. Okay, please make it in a box. When coming to a problem, we know that C equal to rho by M. Okay, C equal to rho by M. Rho is given, M is given. Okay, rho is given and M is given. So rho is given as 1.2, M is given as 30. So 1.2 divided by 30 is C, molar concentration. We get the total molar concentration value. 1.2 divided by 30 equal to 0.04, right? 0.04. Then we know that here we are finding rho A, rho B, Ca, Cb, right? Initial individual concentration of rho A, rho B and then individual molar concentration and individual mass concentration, rho A, rho B, Ca, Cb. That is what we are doing. And after finding that particular value, we can direct substitute the value for 1, 2, 3. We can direct substitute the values. So initially we are finding the values of rho A, rho B, Ca, Cb. So here we know that Ca plus Cb equal to C. Okay, we know that Ca plus Cb equal to C. That is 0.04. Ca plus Cb equal to 0.04. And rho A plus rho B equal to rho 1.2. Rho A plus rho B equal to 1.2. Rho A plus rho B equal to 1.2. So from this equation, we know that Ca equal to rho A by Ma. Okay, Ca equal to rho A by Ma. So we can write equations for rho A substitute here. Rho A equal to, therefore rho A equal to Ca equal to rho A by Ma. Therefore rho A equal to Ca into Ma. Ca is given, sorry, Ma is given. Ma is given as 24, equal to 24 Ca. And rho B equal to Cb into Mb equal to 48 Cb. Right. And rho equal to 24 Ca and 48 Cb. Therefore rho A plus rho B equal to 1.2 implies, substitute here, 24 Ca plus 48 Cb equal to 1.2. 24 CA plus 48 CB equal to 1.2, and already we know CA plus CB equal to 0.04, right? 0.04 192 24 രണ്ടും ഒരേപോലെ രണ്ട് ഇക്വേഷൻ ആക്കി 24 CA plus 24, and by solving this particular equation we will get the value of CA and CB. അതല്ലേ കിട്ടും. By solving this value we will get the value of CA and CB. And putting that value of CA and CB in this particular, this solve with right? 24, we can multiply this particular 2 into 24 CA, 2 into 24 multiply 2 into 24, so we'll get 24 CA plus 24 CB equal to 24 0.8, and divide the subtract the particular 1 by 2, we will get only CB value itself, and we will get C value. Substituting a CB value, we will get the CA value. നമ്മൾ പണ്ടൊക്കെ ചെയ്ത സെയിം മെത്തേഡ് തന്നെ. And after we getting CA and CB, substitute the value in the particular equation, and we get rho A and rho B. So it is a method to find out the CA, CB, rho A, rho B. Okay. So we will continue in next class. അടുത്ത ക്ലാസ്സിലേക്ക് വരുമ്പോൾ CA, CB, rho A, rho B വാല്യൂ കണ്ടുപിടിച്ച് നോക്കാം. ഓക്കെ. CA, CB, rho A, rho B.